very much and good morning, everybody. So I will be talking about the challenges in applying PCF methodologies to a developing country and small farmer context. Thank you. So first of all, I'll give a brief introduction into PCFs of agricultural products from these countries. I'll show you some case study results, and then I'll talk a bit more about issues that are particularly relevant for developing countries before coming to some conclusions and recommendations. So first of all, a bit of background. The scientific understanding of emissions from agricultural production systems that we have is still incomplete, and that is for agricultural production systems all around the world, but it's particularly true for developing country systems. So this lack of knowledge on emissions from these systems means that they may not be represented adequately in the methods that we use and in their full complexity. So also another issue is that the schemes are mainly designed and applied in industrialized countries with often very little input from developing country stakeholders. And so, as we've just heard, all this means that there are fears of trade restrictions, the exclusion of smallholders, and overall a potential negative impact on development that might result from carbon footprinting and carbon labeling in the export markets of these countries. So the characteristics of developing countries that are particularly relevant in this context are the distance to their markets. There are very diverse situations and very diverse natural conditions, so it's difficult to use large-scale default factors that we have. They will not be adequate. There's a predominance of smallholder farming. The yields can often be low and very variable, and so a low yield for an agricultural product translates into a high carbon footprint per unit of output. There can be low access to high-volume shipping systems as a low-carbon mode of transport. But at the same time, developing countries offer a lot of opportunities for achieving emissions reductions because of their very favorable climatic conditions and often low-carbon production systems. So they may be producing food at the farm gate with much lower emissions than we can do it here. And it's also worth mentioning in this context that the majority of the mitigation potential that is estimated to lie within agriculture is actually in developing countries. So we did some research asking the following questions. We wanted to assess the difficulties that developing countries might have in meeting the demands posed by the various schemes. We wanted to assess the variation that arises when different guidelines are being followed, and we all know that there are lots of different standards and guidelines out there. And finally, we wanted to provide some recommendations for more developing-friendly carbon labeling. So I don't have the time here now to go into the detail of what we did and how we did it, but here are some results. This graph shows the greenhouse gas emissions in percent from sugarcane production at the farm gate. We went to 4 different farms, 3 in Zambia, 1 in Mauritius, and we did the calculations following the PASS 2050 methodology. And as you can see, for the first 3 farms here, these are the farms in Zambia, and this green sector here absolutely dominates the carbon footprint at the farm gate. And these are the emissions from land use change. So we followed PASS 2050, and it says if there was land use change, in this case the conversion of semi-natural forest to agriculture, since 1990 you have to include these emissions. And this was true for all 3 farms in Zambia that had very recently expanded their area. This farm on Mauritius had converted its cropland about 100 years ago, so we did not have to include it. And that's why the breakdown of the different inputs and processes on farm looks different there, with the nitrous oxide emissions from fertilizers being most important. Now, at the bottom, you've got the total kilograms of CO2 equivalents per ton of sugar cane. So for the farm without the land use change, it was the lowest with 26. And for these 3 farms, it varied considerably between 60 and over 200. And that highlights one of the problems when carbon footprinting agricultural systems. These farms were all very close to each other, but the differences in the management and particularly the yields resulted in this huge difference in the carbon footprint. So then we asked the question, what is the contribution of key variables to the carbon footprint that might be different between different methodologies? And again, I won't go through all of this because of time. I just want to highlight the land use change again. Obviously, if you follow a methodology that does not include land use change emissions, you reduce the carbon footprint of the 3 farms in Zambia by between 70 and 80%. And then the differences between the 4 farms become much less obvious, and the competitive advantages and disadvantages will change. This here is if you buy a product on the world market without proper documentation of the origins, past 2050 asks you to use a global worst case scenario for land use change emissions. So in the baseline, which is the 0% line here, we had land use change emissions included for the farms in Zambia, but this was not the global worst case. This was the situation for Zambia. So if you include the global worst case emissions on top of what's already in the baseline, you still increase the emissions by about 160 to 180%. Now, for Farm D, we didn't have any emissions from land use change in the baseline, but if we have to assume a global worst case, the emissions increase by nearly 2,000%. So clearly this is an issue of very significant importance to the competitiveness of the product in question. So now I'll talk a bit more about issues that are particularly important in the developing country context. And I'll come back to the land use change straight away because we've seen that this is a very important issue and can dominate the PCF. And this is far more likely to be an issue for developing countries than industrialized countries because they are still actively converting and expanding their agriculture. So there's an imbalance and a bias against these countries in the methods. There can also be difficulties in choosing the correct pre-conversion vegetation type. For example, if no remaining habitat is on the farm or near the farm, and then you have to make assumptions, you might end up overestimating the emissions. If you know the habitat and you consult IPCC guidelines to calculate the emissions that are arising from this land use change, you will see that there are very large ranges of some of the major input variables that you have to use. And this highlights the lack of our scientific knowledge. It also highlights the problem of using large geographical scale default factors. And again, if you use the default factor that maybe is somewhere in the middle of that large range, you can end up very much overestimating or underestimating actual emissions, and that this can have an impact again on the final PCF and the competitiveness of the product. The 1990 cutoff date for the inclusion of land use change emissions, that's in the current version of the PAS, may penalize countries that have poor historical records of land use and land use change, because then you are required to use a national worst case scenario. And of course, the global worst case scenario approach can greatly or will greatly overestimate emissions for most cases, but the thinking is to encourage better documentation of origins. And I think that's very important to increase the or encourage better documentation and traceability of products through the supply chains. Now, other issues that we found to be difficult and important when we did the work was the lack of relevant data. We spent about 3 weeks in the case study countries, and we still could not get all the data we wanted because simply there were no records. So we talked to a lot of people, but we could not get all the answers. Another very important factor is the lack of emission factors that are relevant to the developing country situation or even the particular country you are working in. For example, on Mauritius, we had real problems getting an emission factor for the electricity. And there's generally a lack of emission factors for these countries. Obviously, the numerous different methodologies that are emerging are a problem because these countries may have the greatest problems in adapting to these new standards in any case. But with all these different methodologies coming up, that will be even worse. Developing country agricultural systems are often quite low in capital inputs and rely heavily on manual labor. But this is not reflected in most of the current methodologies, so they cannot benefit from this potential carbon efficiency. And also agroforestry systems, tree crops, they store carbon, so they can help towards mitigation. But again, this is not included in the current methodologies, and so there's also no incentive to increase the use of or the carbon storage on farm. Now, smallholder farmers face problems in addition to that relating to the cost of data collection, cost in terms of time, in terms of training, and development of recording systems, etc. So this may be cost prohibitive for many small businesses to try and join in these schemes. There are low economies of scale for the small farmers, so the larger estates may be better able to absorb the costs associated with this, so there might be a bias towards the larger estates. And other issues that also apply to other standards in the food sector include limited access to information on all these different standards that are out there, information on markets and market requirements, access to training, extension, technologies, and also sometimes certification bodies. And once again, the proliferation of standards will obviously also be quite difficult for the smallholders and small businesses. So I want to conclude with some recommendations and what can be done. First of all, we need to develop low-cost approaches to the calculation and certification of PCFs in order to prevent this trade barrier or exclusion of small businesses. We should support capacity building, as mentioned earlier, awareness raising, extension service, all these support mechanisms. We should think about how to include land use change. I believe that we should include it because it's a very significant source of emissions worldwide, and we should try to reduce this. But maybe we can further develop the methodologies to do it, for example, by developing regional and also crop-specific worst-case scenarios, and also have some debate about this 1990 cutoff date for the inclusion of the emissions. We should research and consider soil carbon losses, in particular from organic soils and peaty soils, because these are very large stores for carbon and they can release a lot of carbon, and we should disincentivize the use of these soils by including them. Also, sequestration and storage in agroforestry systems as a benefit, so these developing countries do not only suffer from the need to include land use change emissions, but can maybe also get some benefit for these mitigation measures. We urgently need accessible databases for tropical regions and more regionally broken down emission factors. Retailers and industry should declare their calculations, we've heard about that yesterday as well, to increase the transparency of the whole process. And finally, we should consider combining carbon footprints with other environmental and or sustainability indicators, because we know that this is not a measure of overall sustainability. So I think I'm just within my time now, so thank you very much.